Hey guys! When I was getting started developing with Appian, I would sometimes get stuck trying to figure out the platform on my own. I looked on YouTube and I couldn't find many technical Appian video tutorials that were also hands-on with the platform. Later, I learned that these videos are instead posted in the Appian community. So if you haven't done so already, please create a community account and then look under training and online, which has a good set of training videos that can help you get a more in-depth understanding of the platform. Also, in the discussions tab, you can post technical questions to the Appian community, which has been a great resource in my experience. In this video, we will be learning some of the main pieces of Appian and be hands-on by building parts of a timesheet application together. Since Appian is constantly improving, I imagine various pieces may look substantially different depending on how far in the future you're watching this. Also, a disclaimer, while I have attended Appian training and earned certification in the past, I am not affiliated with the company, so I can only show you my own approach to developing. There's a lot to cover, so we are going to be moving fast. I'll leave documentation links in the description in case you want to pause and refer to them. Having said that, let's get started. As a developer, you will usually have at least 3 Appian environments or websites. One for development, one for testing, and one used for production where your end users work. You will likely be developing in the development environment and transferring your application and database changes onto the next environments. You will see Appian structured in what I consider 4 main parts, each with a different access page. These can be typically opened from the top right menu. We have the Appian Designer, which is the page we are currently in and is likely where you will be spending the most amount of time in developing your applications. We have a database. By default, in Appian's cloud offering, this is a MySQL database with a PHP MyAdmin interface, but this can vary from company to company. We have the admin console where you can set up most administrative configurations such as custom branding, adding community plugins, or setting up new users. And we have Appian Tempo, which is by default the main area that your users will have access to, although you can also define other customized user access areas called sites, as we will see later in this tutorial. Tempo is structured into 5 main tabs: News, Tasks, Records, Reports, and Actions. Each tab will surface to your users a certain type of data or functionality. To make this video hands-on, I want to jump ahead to development, but we will learn more about some of these 5 later on in this video. At the time of recording this video, the most common use of Appian is for business process management. In other words, you will most likely be creating an internally facing business application. So I will demonstrate what this may look like by developing a basic employee timesheet application. We will first build functionality that will collect hours from employees for a certain day and store these in the database. The first thing we will do is go to the Appian Designer to create our main application object, which functions like a folder where we can keep all of our development objects pertinent to our application. I will name it TST Timesheet App. Next, if we click into our application, we can create our main group, which will be TST Employees. We will also later need to create a couple of groups to help us with backend security and error notifications. So I will also add TST All Users and TST Administrators. You can create groups inside other groups. So I will add our other groups inside TST All Users. Now that we have our group set up, we will need somewhere to store our data. So I will create a Datastore, which is an application-side representation of our database and will hold our mappings between database tables and views and application-side data types. A data type is an application-side representation of the structure of our data. So most likely, a lot of your data types will have the same fields as your database tables. We will now create our first data type. I am visualizing a form that employees can submit that will log hours worked for a particular day. So I will need a unique identifier, which is required by Appian to be able to save to the database, a numeric field for hours worked, a date field, and a text field with the username to record who submitted the hours. Now that we have our timesheet log data type, we now need our timesheet log database table. The Datastore object can create it for us. We can close this tab to go back to our application and open our Datastore object so that we can link the timesheet log data type to the database. We can press Add Entity. The name on the left-hand side, I usually just leave the same as the data type's name. It does not affect the name of the database table, which will be by default the name of the data type. When you click on the field on the right, it will bring up a search window where we can look up and select our timesheet log data type. Now, if we save and scroll down, we can push here to verify, which will compare our Datastore's data types to our database tables and views to make sure all of our tables and views exist and the fields between our application data types and the database table or view columns match. On doing so, it brings up an error indicating that the matching database table does not exist and offers us to either create it automatically or to download the SQL script so that we can create the table ourselves. If we press save and publish, it will generate the table automatically and re-verify our mappings, which shows us a success message. Going to a database, we can see that the timesheet log table was created with the correct column types matching our data types fields. One drawback of this method of generating the tables from our Datastore is that as of Appian version 19, the fields and tables are by default made in lowercase and without underscores. If you are not picky about your database table naming, this works perfectly well and you can keep things as they are and skip to the next step. In fact, by default, various low-code platforms don't give you access to a database, so usually you will never see this part. But if we do want to make these with proper casing and punctuation, we can make changes to the database table and column names. But now the Datastore will throw us an error again, indicating that there is a misalignment between what it sees in the database versus our data types. This type of Datastore error will prevent you from writing to the database table from your application. If you encounter it, one way to resolve it is by editing your data type's XSD file, which is the underlying code that defines the data type. Here we can explicitly state what database table or column names the data type points to. Doing so will put our Datastore back into a verified state. Okay, so at this point we have our groups and tables, and we can start building out the logic of our application. These objects will require a folder, so we will now create our first folder that will house some of these objects. Appian will also sometimes require us to have constants that point to Datastore entities to be able to write to each specific database table. So we will create a constant now and make use of it later. We now want to design the main interface where employees can submit hours for a certain day. I will call this interface TST Timesheet Submission. You can rename any of the objects we are creating as you see fit. In most cases, especially with recent Appian versions, Appian will detect the change to the object and update all references to that object so your application is not impacted. In the Interface Designer, we can see that we are presented with some templates. So for example, if I choose Request Form, it will automatically populate the interface on the left with an example that we can modify to fit our needs. You can undo and redo changes at the top right. Reverting our action, we can see that we can also create our form from a data type using the builder below. In Appian and a few other low-code platforms, it is common for forms to be used for both entering data and previewing the entered data after it has been submitted. We will come back to this, but for now, we will use the interface for editing and submitting once. So I will enter the data type's name and select Editing Data. If your monitor's resolution is low, you may struggle seeing parts of a form, so you can simply zoom out on your browser to see more. On Windows, this can usually be done by holding down Control and pressing minus, or by holding down Control and scrolling out. In Appian, you can call a form like a function, where you can pass it parameters called rule inputs as seen at the top right of the screen. If you call this interface from a process, you will not only be able to pass data into the form through the rule inputs, but also be able to see the values of these rule inputs after the interface is submitted to collect any entered data. Our main parameter here is the TST timesheet log data type that we made. So if we wanted the user to see some data that was pre-filled in, such as the date, we could pass it into this interface under this parameter. Our other rule input is the cancel action, which will contain a true or false value indicating whether or not the cancel button was pressed. On the left-hand side is the palette, which has items that we can drag and drop into the interface. So if we wanted a drop-down field, we could add it in here. On the bottom right-hand side, if we select a component from the interface, we can see and change its properties. We can look at the properties of the username field, for example, which we probably don't want the user to be able to edit, since we want each user to only be able to submit their own hours rather than hours for a different username. There are a few ways to handle this field, but for now, I will remove it. We can also make the date and hour fields required to prevent blank submissions. Then we can press Save at the top right or press Ctrl S. If you are ever analyzing existing interfaces, you can rest assured that as long as you don't press Save, nothing will change. We have been working in design mode, which is friendly for beginners, but if you would like to take a deeper dive, another thing we can look at is the expression mode, which you can toggle up at the top, and it will bring up this window on the left where you can make changes to the underlying Appian sale code that defines this interface. If we click into the parentheses of functions, Appian will display a summary of their documentation page at the bottom left. It looks like our interface is at the root level defined as a form layout function, which has a label, some contents, and a set of buttons. You can collapse functions by clicking on the arrows on the left to get a sense of the parts and subparts of the interface, although in recent Appian versions, you can do most of what you can do in expression mode in design mode. Now that we have our interface, we can create our first process model that will bring together all of the pieces we have made to this point. Appian requires us to have a process model folder to keep track of our processes, so we can create it here as well. Once inside our process model, the first thing we can do is to adjust the process properties. In the General tab, we can customize things like the process name or time zone that it runs in. One of the most important pieces while creating a process model is to customize the alerts. If you do not do this, by default, your process model will send emails to all process and system administrators in your environment, broadcasting any errors or other notifications coming from your process to your team members. Also, keep in mind that since Appian users are environment specific, we always want to define a notification group here. If you define any specific user here, when you deploy your process to your test or production environment, it will crash with an error indicating that the defined user does not exist. To save our process, we can click File Save or just Ctrl S. Now we can go to our TDI administrators group and add ourselves as members so that we can receive any process notifications. Back to our process, we would like to make two main nodes, one to collect form responses and one to write those responses to the database. On the Start node, we can right-click and select Process Start Node. This will make it so that the process will not officially begin running unless the interface is submitted by the user. I will fill in the name of our interface here and press Yes to automatically create process variables that will capture the responses of our form. As we had previously seen, these are the rule inputs to the form, which are interface scope variables reachable within this process node. But the process model has its own wider scope variables reachable anywhere within the process. Clicking Yes here automatically created process variables in our process model and mapped these to the interface rule inputs. If the form is canceled, we want to skip writing to the database to prevent saving empty responses. So we can drag and drop an XOR node here that will take care of this logic. The next step will be to add a node that will write to our database table called Write to Datastore Entity. Now that we have this node, we can finish up the links to route our logic appropriately. In the Write to Datastore Entity node, under the Data tab, under Node Inputs, we must first provide the Datastore entity to write to, which will be our TST timesheet log table. We must now provide what to write into the table, so we can click New Input. The name is flexible. For the type, we must include the data type that we made. For the value, we can set that equal to the process variable that will at this point in the process contain the user's responses provided in the first node, which was the interface. If we save this process, it throws us an error indicating an issue in the XOR node since we have not yet completed it. Going to this node, we can add a new condition and press the blue edit icon to bring up an editor to define the condition for the if statement. In this editor, we can click on variables on the left-hand side to insert them into our expression. So we will add our cancel process variable here so that our logic says that if the cancel button was pressed, go directly to the end node. At this point, we can save and publish or Ctrl-Alt-S on Windows, which will create a new version of our process that will allow us to run it. If we press Ctrl-D or go to File, Start Process for debugging, it will execute the process so that we can test it. Here, I will fill in the form and press Submit. You can use a refresh button up at the top left to get an updated diagram of the running process. The blue highlights indicate the path that was run. As we can see, it is indicating that it wrote to the database and reached the end node. So I will open the database to see the saved data. It looks like it saved successfully, but we are still missing the username, as we wanted this to be automatically filled in based on which user is submitting the form. Going back to our interface, if we click on the Submit button, we can edit the value and add an expression that will capture the logged in user's username. Then, under Save Value To, we can select the username field under our timesheet log data type and press Save. Now going back to our process model and pressing Ctrl D, we can resubmit our form, and going back to the database and refreshing, we can see that the username field is filled in the new row. Up to this point, we have tested that we can submit hours under our system administrator account while debugging our process. However, we would now like employee users to do this instead, perhaps under a website to submit their hours. For this, we will need a user account to test with. We can create it in the admin console under Users and click Create. Keep in mind that usernames in Appian are case sensitive, so if you type uppercase letters here, we will also need to do so while logging in. I will name our test employee Evan and create a temporary password. I will also add Evan to our TST employees group. Now we can log in as a user. Since we're already logged into Appian under our system administrator account, what I usually do here is to open an incognito window in Chrome, which is Ctrl-Shift-N in Windows, so that I can log into both users at the same time. Logging in, Evan is redirected to his default start page, which currently throws us an error since Evan does not have access to that start page, although he does have access to Tempo. In Admin Console, we can customize the start pages of the TST employees group so that Evan is directed to the Actions page in Tempo, for example. Logging back in with Evan, we can see that he is now sent here directly. The next thing we can do is to create an action link for our process in the Actions tab similar to one of the links we see here, so employees can access our form. We need to do a few things in terms of security to make this happen. By default, our application is restricted only to system administrators, and we need to take some actions to surface different parts and objects to users. First, we need to publish our application. Then, under Application Security, we need to give TST employees view access to our application. Under Application Actions, we can create a new action and link it to our TST timesheet submission process. Refreshing the Actions tab under Evan's window still shows us that the Action tab is not there. This is because we also need to adjust security to our process model and give the process initiator role to the TST employees group so that Evan can start the process. Now, refreshing the Actions tab, the Submit My Hours link shows up for Evan. We can fill in the form and submit it. Going to our database table, we find that the entry did not save. We can diagnose this kind of issue by going to the Monitoring tab inside our application, which shows us our process instances. This top one is the one that Evan was just running. We can click it to see what went wrong with that specific submission. It looks like it crashed while trying to write to the database. We can double-click this node to see the error, which mentions that Evan did not have permission to write to the database table. At this point, we could give TST employees permission to write to the database, but thinking about security, we may want to instead work around this with process model logic to not give unnecessary permissions to groups. Here we can create swim lanes, which allow us to make the form node in the process be executed by the user that executed the process while keeping the database writing part to an administrator role. So we can set the nodes in the bottom swim lane to run as whoever designed the process model. If you export this to another environment such as test or production, it will simply run as the user that imported the process into the environment. Once we save and publish, returning to Evan's window, we can give it another try and submit. Returning to the database, we can see that the row was now successfully added to our table. One thing that may be nice to have is a custom site that employees can access that would take them straight to the form so they could bookmark it. For this, we can simply create a new site object. Here we have a few site settings such as site colors and branding. We will leave this for now and simply add a single page to make a simple site. But we could expand on this site later with other pages to include more features. We can link this page to our process so that accessing this page within the site takes us directly to our form. The last thing we will need is to adjust security to our site to allow TST employee viewers. Now, refreshing Evan's view, we can access our form. Tying back to what we learned previously, we can also choose to make this our TST employee start page so that users in that group are directed to this page on login. Now, when Evan logs in, he can see this page and can make a submission, which we can then find in the database. This is the end of the development of this first simple functionality for submitting hours. There are a few things we skipped, such as validations to ensure only one submission per day is sent per employee. We could also schedule these as tasks to be sent out daily to employees at the end of each workday as a reminder to submit their hours. However, one of the main things we may like to do next is to display employee timesheet submissions, which we could then surface to an accounting department group or to show each employee their own submissions. Appian makes it simple to develop with records and gives us a framework that we can build on for viewing and managing records. And if we went into reports, also aggregating this information into graphs and other visualizations. If you are the developer designated to design an application from scratch from a set of end-user requirements, I would first try to visualize these requirements as needs for certain types of records, and then think about which actions and processes you would need around these records. This is also known as data-driven design and is naturally encouraged by the Appian platform. We will soon create our record and name it Timesheet Submissions. However, we will need to make some changes. When we designed our TST timesheet submission interface previously, I had selected to create a template for editing only. But as we now need to view timesheet submission records, instead of creating a second interface specific to only viewing records, we can reuse and extend our existing interface to also allow viewing of records. The first thing we need to do is to create a new rule input into the interface, such that we can tell the interface if it should display in view or read-only mode, which we can trigger if read-only is passed in as true, or in edit mode, which will trigger if read-only is passed in as false. We can make specific fields read-only conditionally, so that the user cannot edit fields when read-only is passed in as true. Under Properties, for read-only, we can click to edit as expression and type in !read-only to refer to our rule input, such that when the parameter is passed in as true or false, it will configure this hours worked field's editability correspondingly. Under label position, it may be nice to display the response to the right of the label when it is read-only instead of underneath it, which we can use in edit mode. To do this, we need to somehow make this property get the text adjacent when we pass in read-only as true and above when we pass in read-only as false. Inside this box, we are now writing in Appian Sail language, which is very powerful and surfaces to us a lot of functionality that can be used for complex custom logic. For now, we will simply use an if statement which works similarly to an if statement in Excel, where the first parameter is a true or false condition that will trigger either the second or the third parameter of the if statement. We can do the same to the second field in our form. One nice thing about Appian interfaces is that they can be tested directly in the editor without needing to run it from a process. We can click Test to assign values to our interface inputs. When used to preview data, our forms data will be passed in under this first rule input. We will tweak it with some data and also set read-only to true. Then press Test Interface to see how the interface displays when it is set to view mode. So even though the username data is being passed into the interface, it is not displaying. So I will add it in and set up its properties. We will not display this field in editing mode, so we will use the onlyShowWhen property to only show this field under read-only mode. Similarly, we want to display the layout with the buttons only when read-only is not true. So we can use the not function, which will return the opposite of the true or false value it receives. After this, we can save the form and test it under both modes to make sure things look okay. Note that pressing submit under edit mode will not trigger a real submission. This is because we are unit testing the interface alone. This interface also happens to be a node in our main process that also saves to the database. So if we wanted to test submissions, we would need to test the process instead. However, while inside the interface designer, it will not trigger the process to start. Since we have changed the rule inputs of the interface, we need to update all places that use this interface. Appian has a dependency tree view that can help you find these places if there are a lot, but for us, it is just our one process. Here, we can edit the properties of the process start form node to pass in false for read-only, so that the process continues to work the same as it did before, and then save and publish. We can continue to use this process whenever we need to create a timesheet submission, and if we wanted to, we could also expand it to allow the editing of previous submissions. For viewing submissions, we can create a record type. The plural name will be displayed to users as the main link to the record list in Tempo. Here we can configure our record's data source as our timesheet log entity. There are options to apply a default filter here if we wanted each user to, for example, only see their own submissions. Going to Tempo, under Records, we can see a new link for timesheet submissions. Clicking into here will by default show us a list of all submissions with pre-created columns that we will want to tweak. For example, this is missing the date column. Under the List tab in the record type, we can press Edit List to configure these columns. I'll move some columns around and add the date column, which will be sortable based on our date field, will be of date type, and will contain our date as its value. For the username field, we can see that it is currently a link. This is a link intended to display details on the timesheet submission row being clicked. So it does not make sense for the link to be under the username field, but perhaps rather on the ID field. So I will convert the username column to a text type column displaying the username. I will then make the ID field a link to the record being accessed in the same way that we saw the username field was configured, and then press Save Changes. Refreshing our timesheet submissions page, we can see our layout properly updated, showing the ID with the link to the timesheet submission for viewing. However, if I click on the link, it takes me to a blank page because we have not yet configured it in the Views tab of the record type. Before we do so, one nice thing we can do is to allow exporting timesheet submissions to Excel, which will bring up this button. When we click it, it will download an Excel file with the data. Back to our record type, we can surface to the user filtering options on our records beyond the default search bar. For example, we may like to give the user a filter to limit records shown in the grid to a specific day. In the Views window, under Summary View, we can call our interface in view-only mode to replace our blank page. However, our interface also requires us to pass in the data to be displayed as the first rule input. So when passed in as null, all of our fields are blank. So we need to find a way to query this data from the database to pass into this first rule input. We can do so by creating an expression rule. An expression rule is a reusable function, similar to an interface, that you can provide rule inputs to, and it will produce an output based on your customized sale code. Expression rules can be called from basically anywhere where there is an expression editor, including records, processes, interfaces, other expression rules, and various other objects that we did not get to cover in this tutorial. For now, we will use a query editor that will generate a sale code expression for us, which will query our timesheet log table. We can add filtering and sorting here on our query. Basically, what we need to do is to pass this expression rule an ID for a timesheet submission and get back just that one entry. So I will create a filter that will query only the passed in ID into the expression rule when it is passed in. As you can see, when we pass in the ID rule input, it limits our query appropriately. If we press Generate Query, we get this sail code that contains our query. We can pass in an ID to get just that one submission. The output data is structured in a dictionary with details about our query, such as the batch size, indicating that we are currently only pulling at most 50 results. However, our desired information is within the data section of this result. If we append .data to the end of our query, it shows us just the data section, which is a list of results. If we add a 1 in square brackets to this, it only outputs the first result. I will not add this .data1 snippet to our expression rule because we may later want to extend it to perform different types of queries, but we can copy this snippet and apply it to the output of the expression rule when we call it. Going back to the Summary tab, we can call the expression with the ID of the row and add .data1 after it, which will parse the result as we had seen before. If we now refresh our record type list, we can see that the data now populates properly in the read-only form. From here, we can, for example, surface this to employees in the TST Timesheet app site we made. If we would like to do that, we need to do 3 things. First, we can add a default filter in the record type so that each logged-in user can only see their logged-in hours. Second, we need to adjust security in the record type and Datastore to allow TST employees as viewers. Third, we can add a page on our site and set the type to record list and the content to TST timesheet submissions. Logging in as Evan, we can now see our submitted hours. Alright guys, so that concludes this video. I'll make sure to leave some helpful links in the description to guide you from here. I hope you found this tutorial helpful. Thank you for your attention.